So for this given linear system, we are tasked to solve for this using the Gaussian elimination. Gaussian elimination, in other words, is a process of making a row echelon form of the equivalent augmented matrix of this given linear system. So let's start with creating the augmented matrix, which will include the coefficient matrix and of this entire linear system. So this could be equivalent to this matrix here: 1, 1, 2, and then 8. You have -1, -2, 3, and 1. And we have 3, -7, 4, and then 10. So we have this augmented matrix now from our given linear system. And we are going to apply the Gaussian elimination, or we need to reach the row echelon form in order for us to solve for the unknowns, the x sub 1, x sub 2, and x sub 3. So let's start by applying these row operations. Since we already have a leading one here, so we don't need to change anything from row number 1, but rather we could do this. Let us make these next entries here 0. So for that, we are going to add row 1 and row 2 for a new row 2. And we are going to multiply -3 to row 1, add it to row 3 to become the new row 3, so that this would be 0 as well. So hoping that you could follow this next few discussion. So again, the first row is still the same, and here comes the process for the second row. We're just going to add for our new row 2. 1 plus -1 is 0. 1 plus -2 is -1. 2 plus 3 is 5. 8 plus 1 is 9. That's for the second row. For the third row, we're going to multiply we're going to multiply -3 to row 1. -3 times 1 is -3, plus 3 is 0. So see, we have reached or achieved our goal of making sure that all the entries below leading 1 would be 0. Applying to the next entries, -3 times 1 is -3, plus -7 is -10. Then -3 times 2 is -6, plus 4, I still have -2. -3 times 8 is -24, plus 10, I have -14. Next is we could make this, or let's make this rather, as a leading 1. So we can multiply -1 for our row 2 for it to be our new row 2. But before we use the new row 2, okay, we could also integrate another process here, like saying multiply -10 to the row 2 in this present matrix, add it to row 3, again add to have a new row 3. Because when you multiply -10 to -1, that will become +10. When added here, it will become 0. Since our goal here is for this to become a leading 1, we need to make sure that the next would be 0. So don't be confused about the multiple operations. We take note that this second operation is not using the new row 2 after implementing this operation, but the original row 2 here. But for some of you who are confused with this, you can of course separate this operation here. You do this operation first, or whatever be the result, then apply the next operation so that the entry here will become 0. But either way, I am trying to combine the two operations. So I have here, I'm not combining, rather, we're going to solve them, but let's start with the first operation. The row 1 is still this one here. So when you multiply -1 to 0, it's still 0. -1 times -1, +1. -1 times 5 is -5. -1 times 9 is -9. Okay? Next is the application of this operation, not here, okay, but still on this row here. So let's do this one. Negative 10 times 0 is negative 10. 0 rather, plus 0 is still 0. Negative 10 times negative 1 is positive 10, plus negative 10 is 0. Okay, just like that. Next, negative 10 times 5 is negative 50, plus negative 2 is negative 52. Then, negative 10 times 9 is negative 90, plus negative 14 is negative 104. Okay? So, next is to make this leading one so that we could finalize our our row echelon form, and we will end up the Gaussian elimination. We simply need to multiply all entries in row 3 by negative 1 over 52 to have a new row 3, making this 1. So with that, we'll have this next augmented matrix. It's still 1, 1, 2, and 8. No changes for these entries. No changes for the second row. Sorry, my bad. It's 1, negative 5, and negative 9. And finally here, it's still 0, it's still 0. This now becomes 1. And we have negative times negative is positive, and 104 divided by 52 is 2. So this ends our Gaussian elimination, as this is already in row echelon form. Why? Notice all of the entries here, or leading entries, are all 1 for all the rows, and they are situated where the leading one is not directly below the previous leading one. And this is just a row echelon form, since some entries above the leading one are not yet 0. But either way, we can now solve for this given linear system using this. Where was that? Let me try to copy it here so that we could compare our results here later. So our row echelon form is now 1, 1, 2, 8. You have 1, 1, 2, 8, 0, 1, negative 5, negative 9. 0, 1, negative 5, negative 9. And for the last, we have 0, 0, 1, 2. Sorry. We have 0, 0, 1, 2. Okay. So, we can now solve for the values of x sub 1, x sub 2, and x sub 3 for this given row echelon form. If you have not viewed the video that will allow us to solve linear system just by a given row echelon form, and you might want to check on that at the same channel. But here, we could come up with these new versions of the equation. X sub 1 plus x sub 2 plus 2x sub 3 is 8. Your second equation would be x sub 2 minus 5x sub 3 is equal to negative 9. To be followed with x sub 3, which is exactly 2. This is already given from this row echelon form. So these are versions of your original equation except for the first row, because we haven't changed the first row. Using this value, you will have x sub 2 minus 5 times x sub 3, which is 2, equal to negative 9. Okay? So here, x sub 2 is minus 10 is equal to negative 9. Adding 10 on both sides, x sub 2 is positive 1. And finally, for our last, or the original equation, x sub 1 plus your x sub 2, which is 1, plus 2, x sub 3, which is 2, is equal to 8. You will have x sub 1 plus 1 plus 4 equals to 8. Your x sub 1 is equal to 8 minus 5. You will have a result of 3. So the results for x sub 1, x sub 2, and x sub 3 are 3, 1, and 2 respectively. Of course, if you are not really sure with what you did, you can just simply substitute all the values here. So 3, 1, and 2 in all the equations, and all should be satisfied. I'm just going to leave that to you for your own practice. But this is the result, or these are the answer for this linear system using Gaussian elimination. And thank you for watching.